Okay, so yesterday we have covered, started plane sweep line technique, and is there any question from yesterday's class? Is it clear overall what we are doing, how we are solving the problems, the idea of plane sweep? Please raise your hand if you have a doubt from yesterday's class. All good? Okay. So let's try to solve another example of plane sweep algorithm. And again, we'll solve this example together. Are you with me? Let's try to solve this. So what we have a set of axis parallel rectangles. That means side of the rectangles are parallel to the axis lines. And the objective is to find the area of the union of these rectangles. A naive algorithm. How to solve this problem? Forget about sweep line, forget about computational geometry. If I ask you that we have this problem and we want to solve this. Suppose we have only two rectangles, how to solve it? Divide the complement. Two rectangles only. I want to find out there are two rectangles. So if they are disjoint, then it's easy, just sum. Suppose they are not, then sum of the areas minus the intersection. So what is how to solve it when there are n rectangles? Very good. So have you heard of the term inclusion-exclusion principle? Here it will be useful to apply inclusion-exclusion, right? But if we apply inclusion-exclusion, what will be the problem? There is a problem in applying inclusion-exclusion. Yes. How many terms are there in the inclusion-exclusion expression? So how many subsets are there of a n element set? So checkmate. Anything exponential is not good for computer science purpose. It's kind of a thumb rule. So how to even solve this problem in polynomial time? Forget about n log n, n square log n, n cube log n, n to the power 4, anything. So the naive method, the previously you have seen, it was like n cube or n to the power 4, which we have reduced to n log n or n square log n, something like this. But now we are facing a problem where the naive methods gives a 2 to the power n runtime. Not even polynomial. So how to propose a solution which solves this problem in polynomial time? Okay.
And then at each edges we'll check the when we have new endpoints, we'll check those and then we'll find those areas.
Okay. So his suggestion is to use sweep line technique. So when we talk about sweep line technique, he has correctly pointed out what is the first thing that we need to find out is the event points. He says sweep a line from left to right. What are the points where we need to stop? What are the points here when we are sweeping a line from left to right? It is obvious that the left endpoint and the right endpoint of each rectangle. So, are you with me till now? So, we are sweeping a line from left endpoint, left to right, and we are stopping at the left endpoint and the right endpoint of the rectangles. And if I try to find out the area covered between two event points, what is the area covered between two event points? How to find that? So, this is one event point, right, because this is the left end point of this rectangle. This is another event point which is the right end point of this rectangle, right. This is two consecutive event points, and I would like to know what is the area covered between two consecutive event points. How to find out? Okay. So, if I look at the sweep line and consider the intersection of the sweep line with the rectangles, what that will give us? So, this is a sweep line and I am looking at the sweep line intersection with the rectangles. It will give us set of intervals towards y axis, right. This is one interval, this is another interval. If we take a sweep line here, so this will be one interval, this will be another interval, this will be another interval, and this will be another interval. This is the intersection with the sweep line with the rectangles. Is it clear? And suppose I know how to calculate the length of the union of these intervals, I know somehow. Then what is the area covered between two consecutive event points? Is the distance between these two event points multiplied with the union of the length of these intervals, that I am calling y. Is it clear? So, this is my say y1, this length, this is my y2. So, total area covered is delta x into y1 plus delta x into y2, that is equals to delta x into y1 plus y2. And between two consecutive event points, this y remains fixed. So, what I will do, I will doing the sweep line, somehow I know how to find out this y. How to find out y, we will see. If we know how to find out y, what I will do, I will sweep lines, and if a new rectangle comes, then a new interval will be added to y, and if a rectangle is deleted, interval will be deleted from the list of active intervals. Right? Are you with me? Any doubts? Please raise your hand. So, initially when I was here, what is the intervals that I am interested in? Only this interval. When I am here, I have two intervals. One is this, another one is this. When I have here, I have three intervals. One is this, another is this, and another one is this. So, somehow I know how to find out the union of these intervals. Then I will just, while moving from one interval to the other interval, I will multiply and I have my solution. Okay. Now the question is, we have started with the two-dimensional problem. What we now have is a one-dimensional problem. Between two event points, what I am trying to solve, I have a set of intervals in y-axis, which I can consider as intervals in x-axis as well. And my objective is to find the length of the union of these intervals. Clear? In each between two event points, what we have is a set of intervals. What is our objective? To find out the union of the set of intervals, which I can consider as a one-dimensional problem where we have a set of intervals and our objective is to find out the length of the union of these intervals. Are you with me? Any confusion? Let me know. I will explain again. We will go step by step. Is it okay? Okay. If it is okay, then let me know how to find, if I give you a set of n line segments, how to find out the area or the length of the union of those intervals. I have given you, forget about the previous problem. Now concentrate on the current problem. What is my current problem is, I have a set of intervals and I would like to find out the length of the union of these intervals. How I can do that? Yes.
If the rectangles
Mm-hmm.
are oriented around horizontal and vertical, not doing that way, then first we will take the projection along the y-x axis
Hmm.
to know the distance between two sweep lines. After we take the projection in the x-axis, along x-axis,
Hmm.
then first along event point there is a sweep line. On the next event point there is another sweep line.
You are proposing another solution to the previous problem?
Just to calculate the union of this length actually.
No. Now I have a completely new problem. From two-dimensional plane, we have moved to one-dimensional plane. In one-dimensional plane, what we have a set of intervals. There is no rectangles. And what is our objective is to find the length of the union of these intervals. For example, what is the length of the union of these intervals? Here is from here to here plus from here to here plus from here to here. So this is x1 plus x2 plus x3. This is what we are trying to find out. Given a set of intervals, and from where it came because of the intersection with the sweep line with the rectangles will give you some intervals in y-axis. Now I rotating it to x-axis, I will get exactly this problem, where we have a set of intervals and our objective is to find the union of the length of the union of these intervals. Okay, again, so another good suggestion from your friend is that again go back to our sweep line method. Sweep from left to right. What I will do? At each event point, if there is an active interval before that, we will add the length from distance from the last event point to this event point. If not, we will not add anything. Yeah. So let's call these intervals, say I1, I2, I3, I4, I5, I6, I7, I8. What is the first event point while sweeping from left to right? The left endpoint of I1. Is there any active intervals right now? No. We add 0. Next event point is this one. Is there any active endpoints? So we add D1. Is now next is here. Is there any active intervals? Yes. At this point I will delete I1, the only active interval remains is I2. Next event point is this one. Is there any active intervals? Yes. I delete I2 from the balanced binary search tree. Is there any active interval previous to this? No. We add clear? A basic application of a plain sweep line algorithm. Clear everyone? How much time it will take? To create a balanced binary search tree, we will need n log n time. And we have said that each insertion and deletion operation in a balanced binary tree takes log n time. Right? At this point I am inserting I1. At this point I am inserting I2. At this point I am deleting I1. This point I am deleting I2. So each event point either I am inserting an interval or deleting an interval log n, and I can always keep a counter which says that whether the tree is empty or not. Right? Have a problem with the balanced binary search tree? Do you have a problem with balanced binary? Too much data structure jargon? Can you propose a cleverer method? Do I need to keep a balanced binary search tree? Think. Unless you think, you will not learn. You will know, but you will not learn. Forget about array, more primitive. So I will maintain a sum. Sum is initially 0. This is puzzle. Whenever there is a left endpoint, I add 1 to the sum. Whenever there is a right endpoint, I do a -1 to the sum. When there is no active intervals, the sum will be sum is so at this point what is the value of sum? Here, 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 here. Do you need a balanced binary search tree? No. Just a simple count will suffice. We are just interested in the fact that whether there exists an active interval or not. Right? So what will be the time complexity? We still have to sort the intervals to know which comes, what are the event points. So n log n time anyway we have to spend. So I can solve this problem in n log n time. How I am solving this problem in n log n time? Is it clear? How much time it will take to solve this problem then? Between two event points I am spending n log n time. How many event points are there? 2n. So, n square log n time I have to spend. Clear? Very basic application of plane sweep algorithm. If it is not clear, please raise your hand. I will explain once again, because after this we will go into a little bit more deeper. Please let me know if it is, if till now what I have said is clear to you or not. Oh, for this problem, you have to sort the endpoints. You have to process in the sorted order. Sorting takes n log n time. So, things comes in a step by step manner. If you look at the final result, it is complicated. If you think step by step, it is not that difficult. Is it clear? Again, please raise your hand. Are you okay with this till this point? Doubt? Okay. So, now try to look back. So, what I was doing is, while solving a problem we have to do two things. One is zoom in, another one is zoom out. What we are doing till now is zoom in. We are trying to concentrate on the current problem in our hand. Now, let us try to zoom out. Is there any part in our solution where we are overspending? Can we still able to reduce the complexity further? Is it possible to reduce the complexity further? We have one solution, that is good. We have solved from exponential, we have reached n square log n. But is it the best? Is it the best that we can achieve? Or can we twist some of the things that we have done till now so that the complexity may improve? Exactly. So, what we are doing? We are spending n log n time here. We are spending n log n time here. Next, we are spending n log n time here. But what problem we are solving here is the union of these three intervals. What problem I am solving here? Union of these two intervals. What is the difference between these two problems? Just one interval got deleted. Between, so this is event point say 1, this is event point 2 and event point 3. Between event point 1 and event point 2 I have 3 intervals. Between event point 2 and event point 3 I have 2 intervals. And those 2 intervals are present in between event point 1 and event point 2. Just one interval got deleted. So, every time I am moving from one event point to the other event point, either one interval is introduced or one interval is deleted. if the current event point is a left endpoint, one new interval will start. If the current event point is the right endpoint, one interval which was previously active will be deleted. That is what happening, right? So, now you tell me, previously we are interested in solving this problem. It is like same as binary search. What we are interested in? Finding the area, quickly finding the area of union of intervals. Now, we are interested in a little bit difficult problem. What is that problem? We want to create a system where we can find out the union of the area quickly and we can delete or insert an interval into the system very quickly. What is the problem with a binary search? That if I change my array, I have to spend order n time, for which we have introduced balanced binary search tree where we can insert or even delete in log n time. So, we are looking for a same kind of a data structure or a system where we can store a set of, like a black box, where we will store set of intervals, and whenever I ask that what is the length of the union of this intervals that is being stored now, I will have a quick answer. Also, I can quickly insert or delete an interval into this black box. Quickly means quote unquote preferably on log n time. Anything less than linear, I will be able to beat this n log n time bound. Log n, log square n, root n, anything is good. Question, can we do that? Still with me? Objective clear? Very good. Any questions? So, this is my question. How to maintain sum of the union of the intervals with respect to insertion and deletion. Okay, so what we will do is we will create a data structure. How we will create a data structure? Consider the endpoint. I know at the beginning of the program, when I get this one, when I am here, I know all the rectangles. So, I know all possible intervals that will come while processing the sweep line from left to right. Just y axis intersection these intervals. I know all the possible intervals. That will give me a set of these intervals, right? What are these intervals? It is a collection of endpoints. So, these are the endpoints of the intervals. Now, we have endpoints. Now, forget about all the intervals. Forget about everything above this line. Only concentrate on the endpoints. So, if I have, how many endpoints I will have? 2n. How many intervals, 2n endpoints will divide the whole x axis into set of small intervals? How many intervals? If I have 1 point, how many intervals I get? If I have 2 points, how many intervals I get? So, the number of intervals I get is n plus 1. I ignored the first interval and the last interval, and I am calling these intervals as elementary intervals. So, I have a set of elementary intervals. These are my intervals. So, this is my first interval, this is my second interval, this is my third, fourth, fifth, like this. How many intervals I have? N minus 1. N minus 1. 2, 2n minus 1. Correct. 2n minus 1 intervals I have. 2n minus 1 intervals I have. I create the following data structure. I create a tree. Everyone is okay with I am using a tree. Forget about the data structure. This is a mathematical structure. This is a mathematical structure, right? A tree is a mathematical structure. How I am creating this tree? This is a representation. So, the leaf node of the tree, of this tree is a set of elementary interval. That means this node represents this interval. Are you okay with me? So, please do not hesitate to ask questions. Otherwise, I will not be able to understand whether you are following me or not. There is nothing called a stupid question. There is nothing, believe me. So, please feel free to ask any questions. If it is not, you are not sure how to store an interval in a tree, whatever. Any questions? This is just a representation. I have built a tree where the leaf nodes of the trees are the elementary intervals. What is the internal node? Any internal node is a union of the intervals of their children. So, for example, can you tell me that what is the interval corresponding to this vertex? Is this interval from here to here. For example, what is the interval corresponding to this? Is the union of this and this. What is the interval corresponding to this? Is this is the interval corresponding to this node. This is the interval corresponding to this node. This is the interval corresponding to this node. So, what we have started with a set of intervals. From that we got 2n endpoints. From them we got 2n minus 1 elementary intervals. From this 2n minus 1 elementary intervals, I am creating a tree. which is the way I am constructing is kind of balanced. So, you can expect it to give us a log n time for insertion and deletion, any operation in this. What are the first two intervals? This and this, sorry. What are the vertices? This and this. What is the next interval? Thanks.
Then why there is no vertex corresponding to
No.
second and third one?
This is 1, this is 2, this is 3, this is 4.
Yes, now my question is why there is no vertex corresponding?
This is 1, this is 2, this is 3, this is 4.
Yes, now why there is no vertex adjacent to 2 and 3, which will represent the union of the interval 2 and 3?
No, I am not saying that I will, for every adjacent vertex I will create a node. This is my construction. 1, 2 will be adjacent, 3, 4 will be adjacent. This is how I am constructing. I am not saying that for 2, 3 there will be a vertex corresponding to 2 and 3. No. Let us see why we are constructing like this, how we will use this. Okay? The construction is clear, how I am constructing the tree. Now, I have constructed the tree. Now go back to our blue intervals. This elementary intervals that we have considered is not actually the blue interval. This is a sub-interval of these blue intervals. How can I store these blue intervals in this data structure or in this tree? We will do something like this. We will start with a root node. Suppose I am trying to find out where to store this interval. We will start with the root node and check its two childs, left child and right child. Does this interval participates in both the childs? No. What is its left child? Left child is from here to here, and right child is from here to here. This interval do not participate in both the sides, it only participate in right hand side. We move right. Okay. Next, at this vertex I check whether this interval participates in both the sides. No. We move to left. Now here we will check whether the interval participates in both the sides. Yes, we will go in both the directions. When I reach here, I am trying to find out the interval at this node. What is the interval at this node? Is this interval contained in the blue interval? Yes. So I will store this. Here I will store this blue interval. So this is interval j. So I will store ij. Now I go left, go right. Come here. Does this interval, the remaining interval, participates in both the sides? No, only to the left hand side. I go here and store ij here. This is how I am storing. What is ij? Ij is the union of three elementary intervals. But I am storing ij into two nodes because this is union of this and this, so I can store, instead of storing ij here and ij here, I can store ij in this node. So in this drawing, ij will be represented in 2 nodes. Still with me? Mm-hmm. No. So from where I have started, I know the endpoints of the intervals being pushed eventually. From there we have started. So there will always be a path, either like they participate in both the sides or in left side or in right side. There is no else part. Hmm? This will be static or dynamic. Let's see. First understand that can we store the intervals. How to store the interval. Then we'll come to the fact that how much time it takes. Okay. Now this is the overall idea. How we are doing. This is the algorithm. What we are checking. Starting from the root. Does this interval we are looking for is a subset of the current interval? Then we don't have to look further. For example, in this case, we know that we don't have to look further because this interval stored at this node is a subset of the interval that we are looking for. We don't go any further, we report that node. If not, then we recursively call this into the left subtree and to the right subtree if it participates in both the sides. So I am checking that whether it has some participation in the left side, yes, I move to left. If it has some participation in the right, I move to right. But I have taken a very easy example. An example where the node is stored in only 2 nodes of the tree. But I may have an interval which may start from here and expand still here. Possible? Then from the root, what I have to do, I have to search in this direction as well as in this direction. I'll check in this path. I'll go here. I'll report this actually. Then I'll go here in this direction and I report this and this. So previously, in case of binary search, we are only going in one direction. So we can claim that the time spent in searching was log n. But here in this case, sometimes I am going in both the direction, sometimes I am only going in the left direction, and sometimes I am going in the right direction. So in how many places an interval is stored? How can I say that? You understand the problem here. I want to find out, okay, I know that I can store the blue intervals into this tree. And I have devised a way to store the blue intervals into the tree. But in how many nodes I am going to store? How can I bound that? Can there be an interval which I am storing in n many nodes? Because I have no control. I am searching in both the direction, not in one direction. I know that if I store it in a path, because of the height of the tree is log n, it will be stored in the log n places. But now I am going in both the directions, storing in both the subtrees. then how to bound the number of places, number of nodes in which one interval is being stored? Think. Unless you think, you will not able to understand. Ask me questions. If it is not clear how I am storing an interval, I will explain once again. Okay, let's take the example of this orange color interval.
No, my question is, isn't it the upper in the right side?
Mhm.
Isn't it the upper node that has to be noted, not the down node?
Sorry, yeah. See, at least one person is understanding. You are correct. This is the representation. This will represent it into one down, right? Oh, sorry.
Yes.
Thank you. So this is the representation of the orange one. So what I have drawn is the representation for the purple one. This interval will be stored here, here, and here. Right? So at least to few people this is clear that how the interval is stored. I hope that all of you understand that how the interval is being stored. If you don't understand, please raise your hand. I will give another example. It's not clear? Okay. Tell me the interval.
In that last line,
No, from number to number.
12 to 14.
The only interval is 12, 14, that is easy.
13 cannot count.
12, 14. Can there be interval? So there will be two intervals, right?
No, it cannot be divided into two intervals because it's a single line. There is no other.
No. Give me one interval, one continuous interval that you want to represent it in this tree. So all the intervals has to be some number.
Yeah, that's what I'm saying. There are only 7 lines.
Yes.
So there can only be 14 and 2 endpoints.
Yes.
There are 16 points there.
Yes.
14, in between 14 15, sorry. 15 is something.
No. So what I know that whatever the intervals that I am going to store has n point among these 16 points.
It cannot be 16 now. It is 14 only.
No. Why? There are how many intervals?
7 lines.
1, 2, 3, 4, 5, 6, 7.
There will be only 14 points.
Oh. So what I am doing wrong?
15 shouldn't be there. Then
Yeah. I maybe mistakenly deleted one interval. Yeah. One, 2, 3, 4, 5, 6, 7, 8. So by mistakenly I have deleted one. Sorry for pointing out. Thank you for pointing out. Okay. Now you understood how to insert or delete an interval here. Is it clear to you? No. Let's try to insert one interval together. So only information I know that the interval has to be, endpoint has to be among the 16 points. You choose one interval. 5 to 11. Okay. This is the interval you have chosen. So I'll start at root. Does this interval is a subset of the root or exactly or a superset of the root? No. The interval stored at root is bigger than this interval. So we will not report the interval as root. Does the interval appears in the left side? So what is the interval in the left side? Interval in the left side contains from here till here. Does it participate in left side? Go to the left side. So where is your purple interval? So you go in this side. What is the interval corresponding to this? So from here, from 1 to 9. But does this interval participate in both the sides? Only right. We will go right. Here, both the sides? No. What is the interval corresponding to this? Interval corresponding to this is from here to here. So it's a subset of the interval given. Right? This interval which is stored here is a subset of the interval that is given to me. So what I will do? So I will report V. So this is the one vertex that I would like to report. But I know that it goes to right as well. Go to the right, then again to the left only, then again to the left, and I will report this. So only 2 nodes are needed to represent this purple interval. No, this is still here, right? Yeah. Okay. So I know that each interval is stored in multiple nodes. Question is how many nodes? Why? So his claim is the number of nodes in which an interval can be stored is height of the tree, that is log n. Why? It's written here. Yes. Yeah.
If it is the height first row, it covers all the
Yes.
one is not. If it is not, if we go to the second level and cover the entire some part. If it is including the part, we will use one for that.
Very good. Very good.
Same way if we go to
Formally you are trying to say this. At each level of tree there can be at most 2 nodes which is storing the interval. Why? It's your argument basically. If suppose there are 3 nodes which are representing some interval, in the same level. This is one node, this is one node, this is one node. They have to be consecutive because the interval is consecutive. Now if I have 3 consecutive nodes in the same level of a balanced binary tree, there has to be 2 nodes which are siblings. That means they have the same parent. So instead of storing the intervals here and here, I would have stored the interval here. So in any representation of the intervals, what I will do, I will store the intervals in at most 2 nodes in each level. So in how many nodes each interval will be stored? Two log n time. In 2 log n places, vertices, each interval will be stored. Very nice. So I'll store the intervals in this tree. But what is our goal? At any given instance of time, among the blue intervals that is given to me, subset of these intervals will be present or active in the data structure. Not all of them will be active. Initially, if I look back our original problem, here, initially only this rectangle is active. Then this and this interval will become active. Then this tree will become active. Then this will get deleted. So at any given point, subset of these blue intervals will be active. Depending on which subset of the blue interval is active, we have to quickly report what is the length of the line segment that is covered by this union of these intervals. Right? This is this union I would like to maintain. How to do that? While inserting, what I will do? I'll start from here, move here, 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 and here I will stop. At each node, I will store the amount of interval, that is the length of the interval that is stored in this node. Suppose these are the set of length of the intervals. After reaching here, I will push 4 towards upwards. I will come here, I know the length of this is 3, I will push 3 upwards, then 3 upwards. So what is the total active length of interval here is 7. At each node, I will maintain an amount of active interval inside the node. Initially everything is 0. When I insert this with these values, it becomes 7. Total length, maybe this is 3, but this is not active. The only active part is this, 3 plus 1 plus 3. From here I know that the active part is 4, the length of the interval is 4, I will push it back. This is 7, I will push 3 back from here, so this is become 7, I push 7 back, I will push 7 back here. Let's check another one. Suppose I try to add this 6. 6 is represented here. So initially, before the green interval is there, what is the active part of this rectangle? This node is 3. After this insertion, this becomes active. So 6. what I'll do, I have 4 plus 6, this will become 10. So how many places an interval can be stored? Log n. When I change one value here, suppose I change the active nodes here, how many changes I have to make? I have to change this, 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 log n changes. For one vertex I am making log n changes. How many vertex each interval is represented in? Log n. So how many changes I have to make? Log square n. Log n vertices, an interval is stored. When I change one vertex, I have to make log n changes because I have to propagate the value till the root. Right? If I make this active, this value is 4. So I'll make 4 here, it was 0, I'll add 4 here. This will become 14, this will become 14. Change in one nodes triggers log n operations. An interval is stored in log n vertices. So when I'm inserting an interval, I have to make log square n changes. When I delete an interval, I have to make log square n changes. So in time log square n, either I can delete an interval or I can insert an interval. Clear? Suppose one interval is represented in only one node here. I need the active intervals, length of the active intervals here. How many changes do I have to make? Log n, right? Here, 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 here. Along the path from root to any leaf node, what is the length of the path from root to any leaf node? Is log n. While inserting an interval, a blue interval, how many places I have to make changes? Log n. Log n into log n, log square n time required changes I have to make. So any insert or delete can be done in log square n time. So together this, it can be done in log n time. This log square n can be modified to log n. I will not go into the details of that, but it's present in the slides. If you are interested, you can have a look why this is log n. So in time n log square n, I can find out the area of the union of the rectangles. Why n log square n? Insertion log square n. When I have left endpoint, what I'll do? Insert one interval to my data structure. How much time? Log square n. Insertion, how much time? Log square n. Insertion, how much time? Log square n. Deletion, how much time? Log square n. How many such endpoints are there? 2n. 2n into log square n. How much time? Order n log n. N log square n, sorry. It's tricky, but not difficult. It's just tricky. You slowly go step by step, you'll understand. Again, a quick recap. Started with this problem, but here our objective changes. Now we want to create a data structure or a black box which can report us quickly what is the length of active line segments are, and that should support insertion and deletion in this black box in some sublinear time. That means something less than order n time. log square n root n anything is fine. How to do that? In order to do that, I have created some elementary intervals. And from that elementary intervals, I have created a tree. Now in this tree of elementary intervals, I would like to insert a new interval. How we can insert? We have checked with this algorithm that check first in the root whether it's a subset, then we report. If it is not subset, we check whether it's whether it's in left side and in the right side. If it's in both sides, we go both sides. If it's one side, I go in one side. And find out intersection. Then we prove that any such interval will be stored in at most log n many places. 2 log n many places. And each such insert, each change in each vertex will change log n many values. So together I am having log square n many changes for an insert and a deletion operation. Right? Then altogether, now if we go back to our previous problem, we have a solution in n log square n time. We found a solution to our previous problem, as well as we have created a data structure which supports insertion and deletion of with respect to insertion deletion, log n time insertion deletion of line segments, and they can store the line segments as well. But please note one thing is that this is only possible because at the starting of the algorithm I know what are the exact endpoints of these blue intervals. Otherwise this is not possible to create such a data structure. We know previously that which blue intervals are going to come, and from them I have created my elementary intervals. If I don't know which intervals to come, I don't know how to create the elementary intervals. So in that sense, it's not a truly dynamic data structure. Right? From where I have get these values. These are the endpoints of all rectangles which may come in future. I know this point, that's why I am able to create the elementary intervals. That's how I have created the tree. If I don't know this, I cannot proceed. So in that sense, this is not truly a dynamic data structure. But it's still useful and you can make modification and try to solve many other problems. So, but before I start, again, the slides are inspired from the slides of Mark van Creveld and Shirish Maharaj. So Shirish Maharaj is is a great scholar and a Maharaj in Belur Math. But I borrowed, and this is his actual real name now. We call him Shirish Maharaj. Okay. So next topic that I would like to cover is Voronoi diagrams. So this is a very interesting geometric structure. Suppose you are trying to build an ambulance network for the city of Kozhikode. Ambulance network. So what you know is the location of the ambulances, where they are actually kept, maybe the hospitals where they are kept. And whenever there is a medical emergency call comes to you, you look into the location and your objective is to quickly find out what is the ambulance which is closest to that emergency and send it to that location. Clear problem? So what is the location? How can we model the locations of the ambulances? Is by points in 2D plane. So these are the locations. Right? Now when a call comes, how will find out which ambulance is closest? I am assuming that the distance is a Euclidean distance. Euclidean distance, that is distance between this point and this point is this much. Euclidean distance. So the distance between 2 points are the length of the line segment joining these 2 points. But there may be a rail line going between them. So in real life this may not be the actual distance, the actual distance may be something like this. You cannot just send an ambulance across the rail line. So for this problem I assume that I am only considering Euclidean distance. So how much time it will take to find out the closest hospital or the ambulance? N checks, right? Question is, think about a big city, say New York City. How many ambulances are there? Uber, Ola does this to you every day. In a big city, how many Ola or Uber cabs are around? Many. Order end time is too much. Can you pre-process the data so that you can quickly tell which ambulance is closest? So I want a subdivision of the plane so that for every site point, the points which are closest to this site point than any other point will belong to that subdivision. So, or you take any point here, the closest point among the all other site points is this one. Take any point here, the closest is always this one. This is how I want to subdivide the plane. I will give a formal definition. This is not a formal definition. So our objective is quickly, not spending order end time to find the closest one. You want to know a more exciting example? What happens if you do a Google search? Each document is basically a data in an n-dimensional space. Look at all possible words. So you get a matrix of all possible words, and depending on the frequency of that word in that document, you get a matrix, a weighted matrix of this huge long. And then this whole matrix becomes a point in a very high dimensional space. And your query is also a point in that high dimensional space. Now when a query comes, you quickly want to know in that high dimensional space what are the close by, nearby points or documents which is present in the database. Google does this same kind of problem, not exactly same, but same kind of problem in a large scale. Ambulance, hospitals, garbage. You know that all of your data, whatever you store in internet, in the cloud, they're stored in the multiple places in the world. Today I am here, tomorrow maybe I am in New York. And my Gmail data is stored in multiple places in the world. How Gmail knows that what is the closest site from which it should extract the data so that the data comes to me very quickly? it does exactly the same thing over the whole network of internet. To quickly find out that 100 places where my data is stored, my Gmail, each email is stored in 100 places because of security reason. If there is a server crash at say Kozhikode, they can retrieve data from the server at Delhi. But quickly it has to know which is the server which is closest to me, so that quickly it can give me a result. Basic concept between everything, all these applications is this one. Here in this school I will only discuss how to find a Voronoi diagram in R2 or in the plane, but you can find out in Voronoi diagram in networks, in graphs, in many other places. The metric can be different, but the concept will remain the same. Good. So I'll stop here. We'll continue this in the next class.